Have you ever encountered a statement that seems impossible to disprove, no matter what evidence you might bring forward? Perhaps it was a theory about a hidden influence or an unseen entity that purportedly explains many things but can never truly be tested or observed. When we examine the foundations of scientific inquiry, the capacity for a claim to be potentially proven false, a concept known as falsifiability, stands not merely as a beneficial attribute but as an indispensable prerequisite. Therefore, it is clear that unfalsifiable claims, by their very nature and definition, cannot be classified as scientific. The fundamental principle behind this distinction traces its roots to the philosopher of science Karl Popper, who highlighted falsifiability as a critical demarcation criterion separating science from pseudoscience. Science advances through a continuous process of proposing hypotheses and then attempting to refute them through empirical observation and experimentation. A scientific hypothesis must generate specific, testable predictions. If those predictions are contradicted by evidence, the hypothesis is deemed falsified and must then be either refined or discarded entirely. Claims that cannot be falsified offer no such pathway for empirical testing, meaning they cannot be subjected to this crucial process of scientific scrutiny and potential revision. To effectively evaluate whether a claim holds scientific merit, you should ask a few key questions. First, what specific observations or experimental results would demonstrate this claim to be incorrect? Second, if no such evidence exists or could exist, then the claim lacks falsifiability. For example, a statement like all swans are white is falsifiable because observing just one black swan would prove it wrong. Conversely, a claim that an invisible, indetectable dragon lives in your garage, yet leaves no physical traces and cannot be measured by any known instrument, is unfalsifiable and, therefore, outside the bounds of scientific investigation. The key is to look for the conditions under which a claim could fail. Understanding the principle of falsifiability provides an invaluable tool for critical thinking, allowing you to differentiate between genuine scientific inquiry and assertions that lack empirical grounding. It is not about whether a claim is true or false, but whether it is possible to test for its falsehood. This principle allows us to identify what can be subjected to the rigorous, evidence-based methods that define scientific progress, helping us separate verifiable knowledge from mere conjecture or belief systems that operate on different epistemic frameworks. Ultimately, recognizing whether a claim is falsifiable empowers you to engage more critically with information and to better understand the distinct boundaries and strengths of scientific methodology. By demanding testability, we ensure that our understanding of the world remains open to correction and improvement, fostering a robust and reliable body of knowledge based on evidence and reason.
If you're into this, like, subscribe, and drop a comment.